Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this video is the continuation of circular measure past papers questions. So more questions for practice will be done in this video. So let's start the work. And the question says the diagram shows points A and B, on the circle with center O. So OB and OA, we can see they are the radii. The tangents to the circle at A and B meet at T. We have the tangent at A, AT. We have the tangent at B, which is BT. The shaded region is bounded by the minor arc AB, and the lines AT and BT. Angle AOB is 2 theta radians. We have the angle at center with respect to A and B as 2 theta radians. So part 1, in the case where the area of the sector AOB is the same as the area of the shaded region, meaning this area sector is going to be it's going to be equal to the area of the shaded region here. We have to show that tan theta equals 2 theta. We have to show that tan theta equals 2 theta. So before starting the question, there are a few concepts which we need to revise here. Number one, if we have a tangent AT and BT and they are with respect to the radii OA and OB, then again I should know that OA is perpendicular to the tangent AT. OB is also perpendicular to the tangent BT. So that means OA, which is the radius, is perpendicular, which is the radius here, is perpendicular to AT, and OB, which is again the radius here, is also perpendicular to BT. So this is one very important concept that we should know, that here I should be having the two perpendiculars. The next thing is with respect to O, if we have two meeting tangents at T, if we have two tangents meeting at the same point, which is at T here, then if I draw this line OT, then I should be getting two similar triangles which are BOT, and this should be equal to AOT here, meaning the angle at BOT then shall be equal to 2 theta divided by 2, or we can say the angle BOT or the angle AOT, they should be equal to theta radians. So these are the few concepts that we have to know before starting this question. So now according to the question, they are saying area of sector AOB, is the same. That means it has to be equal to the area of the shaded region. And then we have to show that tan theta equals 2 theta. So here, let's have the sector area, which is AOB. So area of sector AOB, that's not difficult to find in terms of the radius and the theta value. I can say that this is going to be 1 by 2 r square. The theta, the angle BOT, the angle BOA, or I can say that this area of sector is going to be 1 by 2 r square angle BOA, which is going to be 2 theta. Or here I can say that area of AOB is equal to r square theta. The 2's get simplified and I will be having an r square theta here. The next thing is to find the area of the shaded region. So to get the area of the shaded region, so here I can say that the area of the shaded region, this shaded region is actually equal to the area of AOBT minus the area of the sector AOB, which we have found as r square theta. So here AOBT, to find the area of AOBT, I will be I can say that it is going to be twice the area of BOT here, and twice the area of BOT. To get the area of BOT, to get the area of BOT, I can say that BOT is such that we have OB as the radius, and with respect to OB, we have a perpendicular, that is a tangent at T, and this value here is going to be 2 theta divided by 2 here. So BT, to get the area of BT, I should say that area of BT then needs to be 1 by 2 into the base, which is OB, and into the perpendicular, which is going to be BT here. So how to get this angle BT, how to get the side length BT? I can see that with respect to the theta value here, it is going to be the adjacent, OB is going to be the adjacent, and BT is going to be the opposite. Therefore, I can see here that it's representing tan theta, which shall be equal to BT over OB. Or here I can say that it's BT, which shall be equal to R tan theta here. So I have the value of BT. If I substitute this in the area of BOT, then I should say that area of BOT then will be equal to 1 by 2 into R square into tan theta. Therefore, area of AOBT then shall be equal to 2 into 1 by 2 into R square tan theta value here. Or I can say that this then shall be equal to area of AOBT. This then shall be equal to R square tan theta. So if I substitute this area of AOBT, if I substitute this in this equation, which says its area shaded, which is equals to area of AOBT minus area of AOB, then I should say that this is going to be area of AOBT, area shaded, then I should say that this is going to be area shaded, which then was equal to area of AOBT minus the area of sector AOB. So area shaded then will be equal to R square tan theta minus area of AOB, which came out to be area of AOB, which we found as R square theta. And the question said that it is the area of the sector AOB, which was equal to area of the shaded region. Area of the sector was R square theta, which then shall be equal to R square tan theta minus R square theta. Or here I can say that my R square can get cancelled, and I will here then be left with R square common, and I can say it's a tan theta minus a theta value. The R square gets simplified, or it's going to be theta plus theta, which is equals to tan theta, or I can say it's tan theta, which then shall be equal to a 2 theta. And this is what the question asked us to show, that it's tan theta, which should be equal to a 2 theta, and this is what we have shown in this question. Over here. Now the second part of the question says, in the case where our R equals 8 centimeters, so let's taking in the data, it's R which is equals to 8 centimeters, and the length of the minor arc AB is 19.2. So the length of the minor arc AB, this is a 19.2 centimeters. Then we have to find shaded. If I just start working on it, then I can see here that the only unknown that I have here is a theta value. It's 8 square tan theta minus r square, which is again going to be 8 square theta. Or I can say 8 square here is 64. So I can take 64 common, and here I will then be left with tan theta minus theta. So how to get this theta value? The theta value I can very well see here that they have given us the arc length AB. They have given us this arc length AB. They have also given us the radius here, and we know that the arc length formula here is R and the angle at center. Let's call this angle at center as angle BOA, angle BOA here. The question has given us the arc length 19.2 centimeters and also the radius 8 centimeters. So substituting the arc length and the radius, I should be able to find out the angle value BOA. And with that, I should be able to find out the theta value. So let's start substituting all the values here. Arc length is given as a 19.2 centimeters, radius is given as an 8, and angle we can see is a 2 theta. So here, substituting all these values, I can say that it's 9.2 divided by 16, which is equals to the theta value, or theta then shall be equal to 19.2 divided by 16 is a 1.2. Therefore, I can see here that my theta value is a 1.2. I can just substitute this theta value in the shaded area equation over here, in the shaded area equation over here. So substituting that, I should say that now it is going to be area shaded, which shall be equal to 64 times tan theta minus theta. Substituting the theta value, I should say that this is area shaded, which is equals to 64 times tan of 1.2 minus 1.2, and I should be getting here the shaded area value as an 87.818, or up to 3 significant figures. I should say that area shaded here is going to be 87.8 centimeter square. So this then is going to give us the answer for the required question. Next question is taken from Winter 2017, paper 1, variant 3, and this is question number 7 in the paper. And the question says, the diagram shows a rectangle ABCD. It's a rectangle ABCD with AB equals 5 units and BC equals 3 units. Point P lies on DC. Point P, it lies on DC, and AP is an arc of a circle with center B. From center B, we are going to have the arc which is AP. So if we have this arc AP, then it's very much obvious that the radius for the arc AP here should be at 5 centimeters. BA then is going to be the radius to have an arc AP, and the radius then is going to be a 5 centimeters. Point Q lies on DC. Point Q lies on DC. Point Q lies on DC. And AQ here is an arc of a circle with center D. So with center D, again, one thing is very much known, and that is that AD and DQ, they are both going to be 3 centimeters, as they are going to be the radius of the sector ADQ. So we have the two radii, we have two sectors A, B and P, and we have a sector AD and Q, and the radius for ABP, let's draw ABP here. The radius for ABP, this is going to be the radius for ABP, and for ADQ, the radius then shall be equal to a 3 centimeters. DQ, this is also going to be a 3 centimeters. So we have to show that angle ABP, we have to show that angle ABP is equals to 0.6435 radians, correct to 4 decimal places. So we have to get this angle ABP we have to get this angle ABP, and we have to show that this comes out to be a 0.6435 radians. So to get this, we have the sector BAP, and with respect to the sector, we have decided that radius for BAP is a 5. That means BP here is also going to be a 5 centimeters. So that means if I draw this triangle, which is BCP, if I respect to the triangle BCP, I can see that this is a 90 degrees here. BC is a 5, and BP being the radius is also going to be a 5 unit. And if I'm able to find this angle, then with respect to this angle, let's call this angle a theta, or let's call this angle an x. Let's call this angle an x. So with respect to this angle, I know that BC is my adjacent and BP is going to be the hypotenuse. So applying the cosine ratio, I can say it's cos of x, which shall be equal to the adjacent, which is a 3, divided by the hypotenuse, which is a 5. Or here I can say that x is going to be cos inverse 0.6. So this value here comes out to be a 0.9273 radians. From here, I can very easily say that ABP, the angle ABP then can be represented as a pi by 2 minus 0.9273. I have again taken exaggerated values up to 4 significant figures. In fact, I should have taken, because I want the answer up to 4 decimal places, then here I should be going for the angle value as 0.927295 and subtracting from pi by 2, I should be getting the answer, which is 0.6435 radians. So always take some extra values as required so that we will be getting the exact answer, which was a 0.6435. So angle ABP here, it comes out to be a 0.6435, and then this is shown over here. Part 2, in this question, they are asking for the areas of the sectors BAP. They are asking here for the areas of the sectors BAP and DAQ. So the area of sector BAP, for the area of sector BAP, I can see that the radius for BAP is a 5, and the theta value, we just calculated the theta value, which was equal to a 0.6435. So area then shall not be difficult. Area of BAP then is going to be half r square, which is a 5 square theta, which is a 0.6435 radians. And the area of BAP, it comes out to be 8.044 centimeter square. They have asked us for the area of DAQ, and the area of DAQ then, for this we know that the radius is going to be a 3, and the theta value, or ADQ, angle ADQ, was equal to a pi by 2 here. So solving it, I should say that area of DAQ shall be equal to half r square, which is going to be 3 square into theta, and this theta then is going to be a pi by 2 here. Meaning I should say that this is going to be a 9 pi by 4, or 9 pi by 4 shall give us the answer as 7.068, or I can say that area of DAQ is equal to 7.07 centimeter square. Third part of the question says calculate the area of the shaded region. So to calculate the area of the shaded region, this is the shaded region that we have, we shall be using the working which we did in part 2, and in part 2 we found out the area of BAP, which was 8.044 centimeters square, and also we found the area of DAQ, which was a 7.07 centimeter square here. So to find the area of the shaded region, area of BAP, this area here is an 8.044 centimeter square. So when we were finding out this area, we took help of the right angle triangle, which is BPC. We can very easily get the area of the right angle triangle. We already have the area of BAP, and from the rectangular area, which is AB times BC, if we subtract the area of BAP, the sector, and the triangle BPC, then we will be getting the area of this unshaded region here. So to find this unshaded region, which is ADP, let's do some working here. We have the area of triangle BPC. We can very easily get the area of the triangle BPC. It's a 3 here, it was a 5 here, and therefore I can say PC here is going to be a 25, a 5 square. Let's have it as a hypotenuse, which is a 5 square, minus perpendicular square, which is a 3 square, and I can see that this here is going to be 25 minus 9, giving me a 16, or under root 16 then is going to be a 4. So PC here comes out to be a 4. Therefore, the area of triangle BPC is going to be 1 by 2 into 4 into 3, and that will give me the answer as a 6 centimeter square. So I have the area for the triangle, which then can be written as a 6 centimeter square here. This is the area of the triangle, which is a 6 centimeter square. So this means if, and we have the area of the sector ABP, this area here, and this area here was in 8.044. So we have the two areas, and for these two areas, these are the two areas that now we are talking about. And for these two areas, if I just say that triangle for the from the rectangle area unshaded, which is going to be area of ADP, I can say that this is going to be the area of the rectangle ABCD minus the area of BPC and minus the area of the triangle B, P, and C again. So this was the sector, and this is going to be the triangle BPC. So let's start substituting all the values, and we can say that unshaded area ADP then is going to be area rectangle, which is 5 times 3, minus area of BPC, which is 8.044, minus area of the triangle BPC, which is a 6 centimeter square. Therefore, I can say that 5 times 3 is 15, minus 8.04 minus 6, 8.044 minus a 6, or here it's the unshaded region ADP, which then shall be equal to 0.956 centimeter square. So 0.956 centimeter square, it's going to be this area, for which we can say that the area here comes out to be a 0.956 centimeter square. Now we are left with another unshaded region, and for this unshaded region, let's have it in purple. This is the unshaded region that is left over here. So if I manage to get this unshaded region, then only I will be able to get the shaded area then. So this unshaded region in purple, I can say is area rectangle minus area of the sector ADQ. So area ABCQ. So let's now find out the area of A, B, C and Q, and this shall be equal to the area of the rectangle ABCD minus area of the sector. So ABCD, area of the rectangle ABCD minus area of the sector ADQ, for which we already have the value. ABCD rectangle again is going to be a 5 times 3, which is a 12, minus area of the sector DAQ or ADQ, that is a 7.07 as calculated earlier. So it's going to be a 15 minus 7.07, and this shaded area, unshaded area, ABCQ, then is going to be a 15 minus 7.07, and that is going to give us the answer as a 7.93 centimeter square. So these are the two unshaded areas in this rectangle that we have obtained. Therefore, to get the shaded area, now I can say that the required shaded area is going to be area of the rectangle, which is ABCD, minus area of the sector, area of the unshaded region, which is ADP, minus area of the unshaded region, which is A, B, C, and Q. So substituting all the values, area of the rectangle is 5 times 3, which is a 15, minus ADP, which is a 0.956, minus area of ABCQ, which is a 7.93. I will be getting my answer as a 6.114 centimeter square, or I can say that the area shaded, the required area which is shaded in the diagram is 6.11 centimeter square here. So this then shall give us the answer for this question. Next question is taken from Winter 21, year 21, and it's paper 1, variant 1, and it's question number 6 in the paper. And the question says the diagram shows a metal plate ABC in which the sides are the straight lines AB, and the arcs AC and BC. The line AB has length 6 centimeters. The arc AC is part of a circle with center B. Arc AC is from center B, arc AC from center B, meaning the radius for arc AC is going to be 6 centimeters. Radius 6 centimeters, and the arc BC is part of a circle with center A and radius 6 centimeters. So both the arcs here, they are going to have the radius which is a 6 centimeter. Part A, find the perimeter of the plate, giving your answer in terms of pi. So to get the perimeter of the plate, I should know that the perimeter of the plate then is going to be the straight line AB plus the arc length AC and plus the arc length BC. We have to give the answer in terms of pi here. So to get, let's work on the sector ABC. For sector ABC, let's say that this is our angle, which is an x here. That then with respect to the sector ABC, I should know that my radius is equals to AB and it's also equals to BC, and therefore this value here is going to be a 6 centimeters. So I have the radius which is a 6 centimeters here, and we have the angle which is an x in this case. Now working on sector, let's work on sector with center. Here we were dealing with ABC with center B. Now let's work with sector ABC with center A. With center A. So with center A, again what I can see is that radius in this case is going to be AC, and also this is going to be AB, and then again this radius here comes out to be a 6 centimeters. So with respect to the center as A, again the side AC, it comes out to be a 6 centimeters. So if I have three equal sides, then this means this is an equilateral triangle, and for this equilateral triangle, all the angle values here are going to be equal. Therefore, here I can say that the two sectors, they will be having the angle values which shall be equal to a pi by 3 here. They should be having the angle values which should be equal to a pi by 3 here. So now it's easy to get the arc length AC and also arc length BC. Both of them, they are going to be equal. Therefore, I can say that this is equals to r theta. Theta value here is a pi by 3 as decided earlier. Theta value here, it's a pi by 3. Therefore, here now I can say that my radius value is a 6 pi by 3, and this then is going to be a 2 pi. This is going to be the arc length for AC as well as the arc length of BC, which shall be equal to a 2 pi here. So to get the perimeter, I should say that my perimeter here is going to be AB. AB was a 6, and then arc length AC, which is a 2 pi, and arc length BC, which is also a 2 pi. So leaving my answer in terms of pi, I can say that this answer here is going to be 6 plus 4 pi. So this should give us the answer for the perimeter of the metal plate that we have in the question. Part B of the question says, find the area of the plate, giving your answer in terms of pi and under root 3. So to find the area of the plate, one thing is very much obvious, that this part here is representing the sector with angle pi by 3 and radius as 6 centimeters. So here I can very easily find out this area, and I can say that this area of the sector ABC shall be equal to half r square theta, where my radius is a 6 centimeters, and we decided that the theta value here is going to be a pi by 3 radians. So if I substitute these values, area sector ABC then is going to be 1 by 2 into 6 square into pi by 3. Area sector ABC then is going to be a 6 pi centimeter square. So we have the blue region, area of the blue region, which is a 6 pi centimeter square here. Now we are left with the area, and this area then is this segment here. And to find this segment area, I should say that this area shaded in red shall be equal to area segment, and this segment here is for, area segment then I should say is equal to area sector ABC minus area triangle ABC. So area sector ABC, again I can see here that we have an equilateral triangle with all the sides equal to 6 centimeters and the angle measured as a pi by 3. Area sector ABC, I know that the radius is a 6 and the angle is again a pi by 3, which then is equal to a 6 pi as calculated earlier. And area triangle ABC is going to be 1 by 2 into the two adjacent sides, 6 and 6 into sine of pi by 3 here. So this then is going to be a 6 pi minus 18 sine pi by 3, and sine pi by 3 then is going to be an under root 3 by 2, or I can say that area segment here is going to be a 6 pi minus 9 under root 3. So to get the total area, I can see that the total area of the plate is the blue region here. It's the blue region here, for which we found the area as 6 pi centimeter square, and the red segment area here, and the segment area here was calculated as 6 pi minus 9 under root 3. So the total area of the plate is going to be the sector area in blue plus the area segment in red, which is a 6 pi minus 9 under root 3. So total area here then is going to be, area total is going to be a 6 pi plus 6 pi minus 9 under root 3 or I can say that the total area of the metal plate then is going to be a 12 pi minus 9 under root 3 here, and this then is going to represent the answer for the area of this metal plate. So this ends the topic here. I hope the concept is clear, and I have tried my best to just gather all the typical questions that I could found in the past papers for you, so that you can practice well and understand the topic more clearly. So just work on it, and I wish you all the best, and Allah Hafiz. Next video shall be for trigonometry. So best wishes and Allah Hafiz everyone.